Well, thanks everyone for joining. Welcome to episode 1 of season 2 from SteelTalk, I should say. SteelTalk by SteelCorp, a idea that was designed on the back of a napkin by Shane, probably about 12 months ago, and it was great to run around 5 episodes last year, and thrilled to be back on board for 2022. And what's exciting this year is we're going to be speaking to a few special guests, and really excited today to have our structural engineer Julian LUVARA from Melbourne on the call.
G'day everybody, how you going? Thanks for having me today, Josh, Shane.
Thrilled to have you here, and looking forward to learning a lot from you. So let's get stuck into today's episode. And the name for today's episode, I don't know where it came from, but the guts of the steel structure. So we're going to get pretty grisly and ask some of the juicy questions around structural engineering. So let's jump on in. A bit about SteelTalk before we get started. We're a growing family company with 2 locations, one in Northeast Victoria and one in Western Sydney. And we're passionate about design and construct for large commercial buildings and factories, and love going the extra mile to make our projects really stand out. So I'm here today with my brother-in-law, Shane. G'day, Shane.
G'day.
Shane's our head of business development. So before we jump into the technical content for today's session, pretty excited to announce that 2 lucky attendees from today's call will take home a 6-pack of SteelTalk branded lager. Thanks, Shane. Looks good. And a SteelTalk shirt, which we get shed done. So be sure to stick around till the end to see if you're the lucky winner. And if you have any questions, feel free to chuck them in the chat or the Q&A section. We will be running a short Q&A at the end for anyone that has anything that comes to their mind during the call.
It's not a bad brew, that one. I've had it myself. It's pretty good.
It's always there's always room for a SteelTalk ale or lager, depending on your preference. Righto. So Julian, I'm going to hand over to you now, mate. Privileged to have you on board, and great working with you as we have been for the last little while. So Julian, tell us a bit about yourself and your background.
Yep, can do. So yep, my name is Julian. I'm a director here at Aaron Engineering, which is a structural engineering consultancy. I've been working with SteelCorp pretty closely for the last six or so months now, which has been pretty good on a number of projects. Definitely ramping up in the last couple of months. It's been very, very busy here. I've worked as an engineer for about 8 to 9 years now. I started at a company in 2013 named Windward Structures, which was a structural consultancy responsible for large developments in docklands in the Melbourne CBD. I'm not sure if you guys are familiar with the area. Then moved recently, or not so much recently, but in 2018 I left and moved to another consultancy and just worked on a variety of projects across both the residential, government, and commercial sector. So designing apartment buildings, skyscrapers, government offices, long span hospital structures, just a variety of different things. But last year, 2021, just decided to go on my own and started a company together with a fellow director. And yeah, here I am, just doing things my way, I guess. Still as a structural engineer, but with a bit more drive and my direction. So it's been pretty exciting.
Starting your business, Julian, is always a big risk, I guess you'd say. And how you find that transition?
Yeah, it was something I kind of ummed and ahed about for a little bit, but realized pretty quickly that I just had to take the plunge and go for it and figure it out. And that's kind of how I've always done things in life. So it worked out, thankfully. It's definitely different. It's different to working in an office for somebody else. You know, you're responsible for basically everything and the business's direction, but it's been very rewarding. So yeah, wouldn't change it.
It's awesome, very inspirational. And I guess just before we move on, what drove you, I guess, from a technical point of view, or what drove you to start your own business or go on your own?
Yeah, I guess when you work in a consultancy, when you're working in a team, you're working on projects together with other people, which has its pros, but also has its cons. And I started to feel that maybe the direction that the teams were going in, just generally around the industry, because I did work at a few different consultancies, was that performance was being hindered by micromanagement. And I just, you know, just put simply, you know, performance was being hindered by other instances that were affecting timeline and deliverables. So I just wanted to do things my way to see if I could improve on that, and work with clients, work with builders to get better solutions faster. So here I am.
Let's go. I think in our prior catch up, you mentioned that what you were really enjoying was a bit more freedom in design.
Yeah.
So that's inspirational here as well. And I guess all this is about leaving a legacy, or creating first, but also leaving a legacy. So it's well done. I'm glad to hear you're enjoying it.
Thanks.
So I guess we get down to technical stuff and what is structural engineering. The term gets thrown around a lot, but maybe owner builders or investors or project builders aren't too aware of what you actually do. So Julian and Shane, feel free to open the floor up here and go through a bit around what's involved, what are you responsible for, and a big question here, who's liable?
Yeah, definitely. So basically, structural engineer is responsible for creating the structure, creating the skeleton of a client's vision. So, clients will want to build a shed or, maybe a set of apartments. And a building designer or an architect can show you what's required or what's involved from an aesthetic or visual standpoint. But it's the structural engineer that brings that to life and makes that a reality. So we're responsible for the design of the skeleton of the structure that holds the whole thing up. Sometimes clients, developers can maybe be shielded from that, because oftentimes building designers or architects, or if a builder is on board a project early, will just subcontract that part of the project out, and the client isn't really too involved with the engineering side of things. But that's why sometimes a lot of people often just assume that the architect designs a building, and while they do a lot of work, and there's a lot of work involved from an architect or the building designer's point of view, it's the structural engineer that makes the whole thing stand.
Let's go on. So they come up with I guess summing up, they come up with the aesthetics, what it might look and almost feel like, and you make sure the idea comes to reality.
That's it, exactly. Yep.
You mentioned the other day, Julian, that there's two key elements to design: strength, design, and serviceability. Can you expand on that?
Yeah. So the strength design is pretty self-explanatory. The strength of something is how strong and robust it is. So the strength design is what ensures that the whole thing stands and stays upright, basically, for any structure that's going up. That's one part of the design that we need to make sure complies with Australian codes and Australian standards and the NCC. The other part of the design is the feel of it, and that's what engineers will refer to as the serviceability design. Sometimes we'll refer to it as the deflection criteria or the performance criteria of a structure. It's a more common term thrown around by architects and builders and building designers. But basically, that's how it feels when you're in the structure. So if you've ever walked into a building and you've thought, this feels like it's wobbling a little bit, or it feels like the wind is hitting a little bit. I can hear the wind hitting the structure, and I'm sort of feeling that. Or if you've ever walked on a mezzanine floor and you've felt, this feels a little bit wobbly, or it's vibrating a little bit. That's not an issue with the strength design, but potentially an issue with the service design and the performance of it. So a lot of what we do is ensuring that you don't feel that the client or the owner, whoever's in the building, isn't impacted by the feel of it. So the two very important things, and they're very different. Sometimes you can have a structure that's very strength driven. So the strength design of it and the requirements of the strength design is so high that it demands really robust, really strong sections, members, beams, and columns, that serviceability isn't even an issue because the whole thing is so strong. Other times there might not be a lot of loads on a structure, and it might be pretty free from impact from loads. Picture like an open canopy. There's wind will basically flow through it, but they can be most susceptible to noticeable service issues. So they're more likely to sway or to vibrate a little bit more when the wind pushes up and sucks up into the roof of a canopy. So
you're making me think of my the cubby house I built when I was a little kid. Probably not the most structurally sound, but it's certainly like the serviceability perspective. So that wobbling or the creaking that you feel, an engineer must take that into account to make sure the end user is not at all compromised or doesn't feel safe in that environment. And
service has a second sort of like a second sub function in that if a structure moves too much, it can impact the things that go inside of it. So your partition walls, your facade, any additional like interior framing that sometimes gets referred to as non-load bearing. If the structure doesn't comply with the service requirements and it moves too much, then the structure can actually impose forces and pressures on non-load bearing elements and interior elements. And that's why sometimes you get creaking in windows, or you get partition walls that feel like they're squeezing, and you're hearing things move when it gets pretty windy.
Spot on.
I guess as an engineer, what are you liable for?
Yep, that's a good question. We're liable for the structural integrity, basically. So we are required to carry out a design that complies with Australian codes and standards. And there's many of them, depending on whether it's a steel structure, concrete structure, a residential structure, whatever it is. There's a lot of codes and standards and design criteria that we need to design structures to meet. And because of that, we are responsible for any failures or non-compliance issues in the design. So, you know, if it's let's say a column starts to deteriorate, let's say a concrete column starts to deteriorate and the concrete starts to scabble off. If it's determined that that defect is a result of the structural design not meeting certain design criteria, then we're responsible for that issue failing, that item failing, basically. Now, that's why we have insurance and we go through very rigorous design processes to make sure that doesn't happen. But yeah, we are responsible for the structural integrity of any load-bearing structure or element in a building.
And that's why you issue that nice looking certificate that we provide to our clients.
Yep.
To give them a peace of mind that a certified engineer has reviewed and signed off on the design.
Yeah, and not any engineer can give that certificate. We sometimes refer to that as a certificate of compliance or Regulation 126. To issue that certificate, you need to be a registered building practitioner, at least in Victoria. You're able to work as an engineer and provide that certificate in New South Wales for any structure that isn't Class 2. And Class 2 structures are dwellings of one or more dwellings, or one or more occupancies. But basically, you need to be a registered building practitioner with the Building Association of Victoria to provide that certificate. Now, you need to go through the process of being registered, interviewed, vetoed before that. Yeah, before you're able to issue that certificate, basically. So while someone may work as an engineer, ultimately for the design to comply and for the building surveyor to pass it off and for you to get a building permit, you need to go through a registered engineer.
This is why we work with Mr. Julian, King Julian, we like to call him.
Don't flatter me too much.
Good. So next point we're going to jump into is a bit about the process of what's involved in your work, Julian.
Yep.
Some people might think it's just a plug and play program you bought off, online somewhere, but I know there's a lot more goes into it. There's a lot more involved in the process with your stress testing and your calculations. So
yep.
Over to you to talk around a simple process that you guys use for structural engineering.
Yeah. So the simplest way to put it is ensuring that load gets from the top of a structure all the way down into the bottom of the structure. The top of the structure is, most often it's your roof. The midpoints or the points where that load starts to diverge might be your rafters or your roof beams. Those beams need to be supported by something also. So they get supported by your columns, and your columns need to be seated in something in the ground, which is why you have footing. So we take load from the bottom all the way from the top, all the way to the bottom. And then we also need to consider loads from the side, which are wind and earthquake. So environmental factors. And the way we do that is complex, but simple. I guess it's easy for me to say it's simple because I do it every day. But that can involve, gut feel, rough estimates from just past experiences, or finite 3D modeling of structures in software, and then checking that against hand computations and hand design, because we don't like to rely too much on computer programs to design all our structures. In the industry, we sometimes call it a black box. It can do a lot of things, but if you don't know what it's doing, you don't know what you've done, basically. So it's key that we use both forms of design in tandem rather than just solely relying on one, because the implications of something going wrong are quite severe if they do. Spot
on. And as well, we've done a lot of sheds in our history, and we've used a few engineers along the way. And as you say, the older generation, a lot more handwritten notes, and that sort of probably the gut feel from prior experience coming through. But it's good to see a healthy mix between the new approach and the older experience gut feel approach. It's great.
Yeah, we like to get hands on. My generation, at least, prefers to get hands on early in a project. That way, we can see it through from concept to build, basically. Because if we come on too late, sometimes things can get missed, or a client's vision can not be fully realized. Whereas if we're there from day one, we can sort of provide input as things go. And I like to get involved pretty early. That way, I can, rather than just it's very easy for me to throw a quick answer out there and say, yeah, it'll be something like this and she'll be right. But if I'm there from day one, or if another engineer is there from day one, then I like to at least perform a lot of the design early so that I have a full understanding of the structure as we continue to design it and take it to build.
That's a gold point, because as a shed company or a commercial building company, many of our clients are owner-builder clients or investor clients, which is great. We love working with these types of people. They come to us for early design and often budgeting help, because this is something they may only do once in their lifetime. And what I love about what you said there is it's important to get the engineer involved early, because A, it gives us peace of mind that the design's going to work. It's going to make sense. B, it allows us to put our heads together for a preliminary design from a structural point of view. And C, it gives our client or the end user a more accurate budget, because we're able to price according to what has been put down by a structural engineer. So, gold point. Shane, you want to put things out on that point?
Yeah, so basically it comes back to doing the design phase first before signing up on your shed. It's actually might take a bit of time, but it saves you time in the long run.
We've had a bit of success with that as well, haven't we, Shane? I think last year there's a couple of projects that we worked on that you hadn't necessarily won, but you came to me early for input. And I think because you did that, you basically won the project, because we were able to provide the end design before we'd even won it. Some people
That's right.
Some people think that that's a bit not a good use of time, or it could lead to abortive work. But if it goes the other way, it's extremely, extremely effective way of winning projects.
Spot on. Now, next point I'm going to jump into, I think we've got now, is some juicy questions. And shout out to Aaron from the call. I know he likes his juicy burgers. I saw one come up on the feed yesterday. But we've got, I think, 3 or 4 questions here we've come up with Julian, which we think are really important for our audience to consider, either when they're designing their structure or if they have a structure already, things to look out for. So we'll run through these now, and hopefully there's some value in here for our audience today.
Definitely.
So, Shane, I'm going to allow you to fire these questions at Julian, and I'll step in if I've got any other questions as we go through these. Over to you, Shane.
Yeah, Julian, a lot of the time when we need to get a design done, you ask for a soil report.
Yep.
Just wondering how the quality of the soil affects the design.
Yeah, I'm not being annoying when I ask for that. I've got a pretty good reason, which we're starting to appreciate more and more, which is basically that your structure is sitting in soil. At the end of the day, it's sitting in ground. So it's only logical and rational to want to have an understanding of what that is. You wouldn't just go and throw a building on a piece of concrete that you found out in a yard or something that someone had disposed of after they demolished their house. You'd want to know the structural integrity of that element. So if you're going to found your structure in the soil, you want to know what's in it, which is why we will often ask for a geotechnical report. And the geotechnical report, well, the geotechnical engineer goes out there and will do their studies, do a quick investigation. They'll usually drill a few boreholes, and they'll take that back to a lab, sample it, and basically tell me what's the quality of the soil, how strong it is, how robust it is, whether it's susceptible to movement, whether it's primarily fill. And from there, I'm able to then design pretty efficient footings. And footings can add up in cost quite significantly. If you don't know what soil you're founding your structure in, the structural engineer has no option but to assume the worst case or use nearby sites to get an idea, but it's never entirely accurate. So when we're having to design for the worst case, obviously we're assuming that the soil is quite poor. And oftentimes that results in deep footings, and deep footings, you know, it could be the difference between a meter deep footing and a 2 meter deep footing. If you've got 20 footings on a site, all of a sudden you've got 20 meters deep worth of extra concrete that you didn't actually need. And that's money that you could be saving. So by understanding the soil quality, we're able to provide very efficient and the correct footing design. And oftentimes that can lead to savings in the structure and the structure's materials as well, because very robust and strong footings can sometimes be relied on to help take a little bit of the pressure, or the technical term is we rely on the spring stiffness of the footing to move a little bit and sort of absorb some of the movement that the structure is feeling. So that's the technical or semi-technical way of explaining it. But to summarize that, basically, we sometimes use the footings to help take a bit of the pressure off the structure. And that can lead to savings in the materials of the structure too. So the soil report is, it could be arguably one of the most important parts of the structural design, which is why we'll often ask for it, because the structural report can cost anywhere between, you know, $500 to $1,500 maximum, but it could save you 20 to 30 to 40K, just depending on the type of structure, which is a lot of money.
That's gold, man. And just for our audience's clarity, when we say poor soil or good soil, what does poor soil look like?
Poor soil is generally just fill. So any soil that's been moved from another site or moved around or disturbed. So if you've come to a site that's been excavated, then the soil is automatically or generally going to be quite poor because it's been disturbed. Or if the site has been served as a dumping ground for other soil, like you're dealing with soil that is generally of poor quality. And that's not to say that it's the end of the world if you do have a site that's got poor quality soil. It just means you need to account for it and design for it. Oftentimes you can compact poor soil to get the most out of it, but you can't do that, you know, unless you know what the soil is like at the site. So you might have soil in your site that's poor quality, and not know it. And I'll, you know, an engineer will come and maybe design for the worst case. But even though you've got poor soil on your site, you actually could have done a little bit of work to strengthen that and get a better footing design. You just wouldn't know that unless you had the geotechnical report. So in 99, I'd say in 100% of instances, you're always better off getting a geotechnical report.
That's gold. And even if I haven't yet purchased the land for my building, always great to get that insight around the soil, because you say it can add, you know, 30, 40, 50 grand to the footing cost requirements for my structure.
Yep.
Spot on. Any other points in this question here, Shane, around soil?
No, not really for me. I think that's answered my question.
Spot on. Next up is the solar system. Over to you, Shane.
Yeah, we get a lot of clients ask us whether their shed's designed to take solar panels. How would you answer that?
So we're always trying to provide the most efficient design, cost-effective design, because if we're designing for things that aren't actually going on top of our structure or aren't being applied to our structure, we're over-designing it. Now that's got environmental impact and a cost impact as well, because if you're over-designing structures, you're requiring bigger sections, bigger steel sizes, and it's naturally going to cost you a little bit more. So we won't assume any loads on a structure unless instructed otherwise. And a solar system is one of them. We won't automatically assume that there's going to be solar panels on a roof. That's not to say that the structure can't support it if they do go on top of the roof after the structure's been built, but it can lead to issues down the line, because there may be an instance where your structure is being designed to the absolute bare minimum requirements, which is an ultra efficient design, which is how a lot of engineers design things these days. But it's not very future proof, and it doesn't allow you to put extra stuff on top of your roof like solar panels. So it's very good to have an understanding of what you want your structure to support, what you want on your roof, what you might need. You might need air conditioning units also. You might need mechanical units, and those all add load onto a structure and change the design. So if you do have a structure in mind, if there is something that you want to get built, always come to the conversation, to that initial meeting, and make that clear, because it can save you a lot of headache later on.
And with the way the market's going, this request is very common. So as you say, be sure to make that known up front. But I guess just to fasten on one point you mentioned there, with the rising cost of construction overall, every department or area of a build is trying to tighten up. So that's why it's important to raise this point early on to make sure there is provision for those solar panels.
Yeah, definitely.
Awesome work. The next point is all around geographical location. And I know this is a massive topic as it can impact so much of the structure. Over to you, Shane.
Yeah, so how does the geographical location affect the shed, I guess? I mean, they're thinking of snow loading, wind loading, and
orientation.
Is there any other orientation? Yeah.
Yeah, there's two main items to consider when talking about location. The first would be the environmental factors. So anything between wind, which is going to impact every structure, snow, which doesn't impact every structure, and earthquake, which impacts every structure, but isn't a governing environmental factor for low-rise buildings. And I can say that with confidence, having designed a lot of buildings to withstand earthquake load. We don't get a lot of earthquakes in this country, but we do need to design and allow for some degree of them. But basically, wind is going to impact every single structure that goes up in this country and around the world. And it can impact it in two ways. The first is the orientation of the building. So I think Josh has got a diagram that he can share with us here, if you can screen share it.
Yeah, I'll bring it up now, Julian. Just give us 5 seconds.
Yep, I can do. But basically, wind hits a structure from every direction. Naturally, it can, sometimes the wind's blowing from the north or the south or the east or the west. It can't really blow, to get really technical with you, can't really blow from every angle at once, but a structure needs to consider the forces imposed on it from every angle when wind hits it, because we're talking about things like, suction and internal pressures. But basically, generally wind from the west direction is the strongest. And because of that, we like to orientate buildings in this configuration wherever possible, because the structure can take wind from the west and distribute the impact of it all across the building long ways more effectively than it can short ways. And by utilizing this, when a client comes and says they want to build a shed, they want to put on their land, it can lead to cost savings in the project, because if the structure is orientated the other way, I think on the next page we can see this. Should be the page over.
Yeah. No, here we go.
Yeah. This is going to impact the sizes of our steel columns and our rafters or our truss a little bit more than the other direction. So orientation is a big thing. If the orientation is articulated and explained to the client, to the builder, the building designer and the engineer early on, then we'll take it into account. And if we have, the efficient building orientation on the other page, we can provide a better design. Without that information, again, engineers got to assume the worst case. So we do consider the west wind from any direction. So orientation is a big thing. Location is huge though. And sometimes this can get a little bit lost, but basically picture an open field, right? With no trees anywhere. There's no buildings as well, right? If you put a shed or a building in the middle of that open field, there's nothing around it to reduce the impact of wind, to shield. And that's what the term that we refer to as engineers. There's no shielding around the structure. So there's nothing that can reduce the wind load when it hits the structure. But if you put a building in an industrial area that has other buildings around it, or there's a lot of trees around, that can oftentimes reduce the wind loads on the building. So a building in an open plane with no shielding is going to work harder and resultingly have bigger columns, bigger rafters, than a building that's in a built up industrial or residential area, or is near a lot of trees and, has a lot of shielding around it. The other environmental, sorry, go for it, Josh. Sorry.
No, Shane, I think Shane had a question too.
Go for it.
I was just going to say, when you build next to water, does that affect wind loading?
Not necessarily against rivers, but is a big issue when you do it along the coast. So as you get closer to the coast of Australia, the wind pressures get higher. It can impact if you go against the river, depending on geography. I should have sent you the diagram out of the wind code. It's a really good way to explain it. But yeah, basically there's a map of Australia that engineers need to refer to understand the wind region, and that map we basically rely on to work out the wind pressures depending on the location of the structure.
That was going to be my question around the cyclonic areas, but it's covered that well. Sorry, ladies and gents, we are running a bit over time, but I'm not going to try and cut this too short because it's some really good content coming through here. So I guess summing up the geographical point here, Julian, with, as you said, wind's going to affect every structure. Yep. And then we touched on the orientation point, which is something I had found really interesting as well, that we want the west wind, which is often the strongest, to hit the gable part of the shed, because it's able to distribute the load more efficiently. Yeah.
But before, one last one, that's another good one, is alpine and subalpine structures. So if your building is in an alpine or subalpine region, you do need to consider the impacts of snow on the roof as well. That can sometimes catch out a structure. So if you might not know that your structure is in a subalpine or alpine region, but your engineer should, and your engineer will account for it.
Spot on.
And the higher the elevation, the more it affects it.
Correct.
Loading,
yeah.
Doesn't it?
Yeah. The higher up you get geographically, the more you need to account for that with snow.
Right to the last question from our side today, Julian, and it's all around the importance of really smart connections and being detailed with our fixings. So Shane, quick intro to this question before handing over to Julian.
Yeah, so basically, how does the connections and fixings support your structure?
Yep, it's a great question. Basically, the connections and fixings are kind of like a joint. So a joint in your body. So while, if you consider your leg, while your shin and your quad might be working perfectly fine, if your knee isn't, then you can't walk. The same thing with the structure. If you might have, an over-designed rafter and an over-designed column, but if the connection that ties the two together isn't as robust as it needs to be, then you could have issues with your structure down the line, which is why connections and fixings are arguably, they are basically the most important part of a steel structure, and they should never be skimped out on. I like to keep things as simple as possible. So a simple structure is a good structure. The less fixings, less connections you have, the easier everything will be to build, the cheaper it will be to build, and the less points of failure there are basically in the structure. So we had a project actually recently where we had a bit of a design issue, and we had to introduce a lot of different elements that were supporting each other. There was a lot going on. There was a lot of one rafter being supported by another rafter, being supported by another column. And it was totally doable, but it introduced a lot of fixings and connections can get quite expensive too, because, we're talking about 20 to 25 mil thick pieces of steel plate. That's quite expensive stuff. And the cost difference between an M16, or so like a 16 diameter bolt, to a 24 diameter bolt is quite significant when you add them up across the extent of a project. So fixings are ultra important, and yeah, that's why we have a heavy emphasis on detailing when designing steel structures, because the devil is in the details, basically.
And just the last point on this question, as you say, the detailing is so important, and that who normally is responsible for that part of the design?
Yeah, well, the engineer is responsible for nominating the fixings and the connections, and then the builder is responsible for detailing them to suit the engineer's requirements. So as an engineer, I always try to prioritize and focus on making sure the documentation, because the drawings is what ultimately the builder will build the project from, ensuring that the drawings are as detailed as possible and capture everything required. So I like working closely with builders for that reason, because it's important that, yeah, what the structural requirements are for fixings are totally captured.
Awesome. So shout out to any detailers on the call today. Your work is super important and
ultra important,
critical to success of structures.
Yep.
Okay. This is where it can get a bit interesting, and I'm 100% confident that these were not engineered by our friend Julian, these structures we can see on the screen here. No relation at all, but
No.
freak events do happen, and sometimes structures do fail. So Julian, can you just share some experiences you've had, I guess, around anything that has gone wrong, any projects you know that have gone wrong, perhaps due to shortcuts being taken or things being rushed?
Yeah, so look, it's very difficult to determine why a structure has failed. Like, looking at these two images, it's hard to determine what was the sole cause. But you can see that if something does go wrong, especially in a steel structure, it drags everything together with it. And it can sometimes be just one point of failure, or it can be accumulative. It can be something like fatigue in a structure that over time deteriorates. It can be the result of like a freak wind event or a freak environmental event that nobody could have accounted for. Because while we do design our structures for sometimes 1 in 100, 1 in 500 year wind pressures and wind speeds, sometimes that can be exceeded, and it would be folly to constantly design for events that have very little to no likelihood of happening. So I've not worked on any fall down jobs, as we call them in the industry, or any projects that have had severe issues like this. But I've seen a lot of projects get close to. The good thing about our industry, though, is that there are a lot of safeguards and placeholders there to prevent something like that from happening. We've got things, projects go through revisions of drawings. There's, tons of eyes are cast over them. And, you got your building inspector will go out to inspect the building before it's built. Engineer will go out to inspect it too. And a lot of times the things that can go wrong get caught. And that's why we don't really see many fall down jobs or projects that have performance issues in this country. And it's because of that, because the industry is so stringent. So yeah, basically poor detailing is probably the number one thing that leads to issues on site. Because if the drawings aren't clear, or if there's ambiguity in the drawings, then oftentimes, your subcontractor, your builder might take liberties sometimes. And then if they're doing that, then what's actually getting built isn't per the engineer's spec, and then you run into issues. So, and
that can have some flow-on effect throughout the whole project.
It just flows on, yeah. So,
and when you've got large projects, multi stories of millions of dollars, that's going to be quite detrimental, I guess, to the overall structural integrity.
Yep.
Spot on. Okay. So we've come to the end of our technical presentation, which has been, hope everyone's enjoyed it. I certainly have. Thanks, Julian.
No worries.
And we have had a few questions come through, which is always great to see. So I'll throw them at you, Julian, as they come in. So Simon, shout out to Simon, who's on the call. He says, does a building structural integrity get affected or impacted in coastal areas with salt?
Yeah, that's a really good question, Simon. Yeah, it can impact a structure significantly, especially if you've got a steel structure. So steel is susceptible to deterioration. If you've got a concrete structure, again, salt can impact that and deteriorate concrete columns. And if you've got, to get real technical, or to get into the nitty gritty of it, if you've got a concrete column with steel reinforced bars in it, and let's say the concrete used was of poor quality, or it didn't cure properly, or it cracked, basically you get cracks in the column. In coastal areas that have, that issue, the salt can get into the cracks and seep through and then deteriorate the steel reinforcing bars inside of there. And then that will deteriorate the entire column. So it's important to be aware of the environmental factors in your structure. The engineer will almost always take it into account. There's things you can do to prevent that being an issue on your project, like the steel can be treated, it can be galvanized, it can be painted. There's a variety of different things that you can do to prevent that from damaging the structural integrity. But it's important that that is made aware to the client as well, because that can increase the cost of a structure as well.
Sounds like Simon's building his holiday house on the coastal areas, which is exciting. Go Simon. Another great question is coming from Bryce. Thanks, Bryce. In regards to fixings, what dictates when a connection requires a bolt to be tensioned, and when can it just be snug tightened?
Yeah, so basically when there's a moment passing through a connection or a high degree of tension forces, we'll nominate for the bolt to be a TB bolt, we refer to it as. But if it's just taking shear force, so okay, so I'm going to use my hands here.
This is getting technical.
Yeah, I'm going to use my hands here, Bryce, because it'll just make things easier. So imagine the knee of my finger is the column and there's a rafter connecting into it, right? This is what we commonly refer to as the knee. And there's a high degree of forces at the knee at this connection here. So we'll often nominate for these to be tension bolt, to be TB basically, because there's a lot of push and pull. The rafter is trying to rotate and bend the column with it. So it's trying to bend the structure, bend the knee like that, because you've got sort of forces happening you got a compression and a tension. So a push and a pull, right? Two things happening at once. The bolts are under severe amount of stress, but snug tightened is usually just for, let's say we've got a beam coming into a column like this and it's in a house, or it could just be, okay, hang on. It's a column inside of a warehouse, right? There's no real lateral loads pushing against it. So it could be your mezzanine floor, right? In that instance, you've literally just got a downward force on your connection between the beam and the column. So in that instance, it can just be snug tightened because it's literally just what we call a shear force going through the bolt into the plate, into the column. So yeah, that's
a great question, Bryce, and well explained. Julian, all those finger movements.
Yeah, sometimes if you don't have a pen and paper, you just gotta improvise.
Let's go. And I think Ben answered a question earlier in the call, which I think we've hopefully answered. Do you take into account location when you review engineering, example, hailstorm, prone, high wind and snow? So that's certainly factors which are taken into account. And also he's asked, which I don't know if we can answer directly, but what is the cheapest roof design? There's always going to be factors, but pitched, curved or flat, or I'm assuming you mean SKILLIAN. So generally we say, Shane, a gable design is more economical. Is that right, Shane?
Yeah, that's what Julian told me.
Yeah. We find that pitched roofs, so a gable design roof is going to be more efficient and therefore cheaper than something than a flat design. Yeah.
So just for the audience, if you're not sure what those terms are, gable is where we have the peak or the ridge in the center, and then a flat or SKILLIAN is where it slants one way for the entire span. So in general terms, we would recommend a pitched roof or a gable design. But if you want to get technical or go on.
Oh, with curved roofs, you do get certain efficiencies, don't you, Julian?
Yeah, you do. You get the most out of a pitched or a gable roof, but you get some out of curved as well. Flat is going to work the hardest. Flat will work harder.
That's great. So is there any clients out there that think about designing their structure and want to make it stand out? A curved roof is always a unique way to go. That's good. Great questions. So I think we're now to a pretty exciting part of the call, which is who are our winners. And Shane, I know you've got someone in mind who's on our attendee list today that should take home the 6-pack of SteelTalk lager and a shed. Shane, who's our first winner from episode 1?
I see Glenn on the call there. I assume that's Glenn Coolahan. I believe he should take home a 6-pack.
Congratulations, Glenn. Great to have you with us, and it's exciting to be working with you on your proposed project, which is great. And I think I'm going to make this big call, but I'm going to give a second prize to Bryce Earl, because that question around the bolt tensioning was really good and it brought out some really technical points. So winners today is Glenn and Bryce. Well done. We'll reach out to you after the call for your best postal address to take home the 6-pack of beer and the SteelTalk SteelTalk shirts rather, not sheds. And be sure to enjoy the little gift. I'm sorry we have gone over time today, but we are hosting our next episode of SteelTalk on April the 8th. Hopefully 2:30 is a good time for you guys out there. If not, let us know. We can try and play with that a bit. But we're going to be bringing on a commercial builder in April to give us a bit of a rundown around what they do, similar to what Julian's done today, around the benefits of what they can bring to the table and a bit about them, so a bit of a profile on a commercial builder. So be sure to join us for that session. It's been great to have a company this time around. Julian, do you want to add before we sign off for today's episode?
I think I talked you guys' ears off enough today.
But
thanks for having me. It was a good time.
No, thanks for giving up your time, and hopefully our audience found it valuable. It's been great to have you with us. Shane, you got any parting words?
I don't think so. That's all from me.
Perfect. Okay. Thanks, everyone. Keep safe in these rainy times, and we look forward to seeing you on the 8th of April at 2:30 p.m. And be sure to jump online and register that event. Thank you, everyone. Catch up soon.
See you later.
See you later.